It begins in the deep earth. Pure quartz, the raw silica that will soon capture the power of the stars.
Only the purest 1% is chosen. Any impurity now will drastically reduce the solar panel's efficiency later.
Breaking down the Earth, we reduce giant crystals into uniform grains, preparing them for the transformation by fire.
The chemical bond. Carbon is added to strip the oxygen away, leaving only the raw silicon behind.
Descending into the heat. These electrodes will unleash an inferno, reaching temperatures of 2,000 degrees.
Pure fire. At 2,000 degrees, the solid Earth melts, turning into a molten river of raw silicon.
The first pour. Raw, liquid silicon emerges. But for solar power, 98% purity is not enough. Solidifying the foundation. The molten liquid freezes into metallic slabs, a dark, heavy precursor to the solar cell. Breaking it down again. To reach maximum purity, we must turn these solid slabs back into fine particles.
Into the vapor. We transform the solid metal into a gas, a chemical trick to filter out the final impurities. A tower of purity. Each level of distillation strips away one more atom of contamination.
Growing the crystal. In a vacuum, the gas turns back into solid, growing into ultra-pure polysilicon rods. The harvest. These rods are now the purest material on the planet, nearly 100% perfect.
Ready for the melt. These ultra-pure chunks are the seeds of the solar revolution. Phase 1 complete. From raw earth to the world's purest metal, the journey to the sun has truly begun. The journey into the heat begins. Ultra-pure silicon is placed into a quartz vessel, the only material capable of surviving the upcoming inferno. Sealed in a void, we remove every molecule of air to create a perfect vacuum, ensuring the silicon remains untainted by the atmosphere.
The liquid sun, under intense electromagnetic heat. The solid crystals dissolve into
A single seed. This perfect crystal will act as the DNA, telling the molten liquid exactly how to arrange its atoms. The first bond. As the seed touches the melt, a microscopic bridge forms, beginning the birth of a single, massive crystal. The dance of stability. Opposite rotations create a perfect thermal balance, allowing the crystal to grow with mathematical symmetry. Expanding the horizon. The crystal widens, taking on its full diameter, a heavy, solid pillar of pure silicon. Millimeters of perfection. For days, the crystal grows in total silence, a slow-motion miracle of high-tech engineering.
Guided by light, lasers monitor the interface with sub-millimeter precision, adjusting the heat to maintain a perfect growth rate. Creating the charge, we add a trace amount of elements to give the silicon its electrical spark, the soul of the solar cell. A pillar of power. 2 meters of pure, single-crystal silicon, a monolithic structure ready to capture the sun. The final separation. The crystal disconnects from its liquid origin, becoming a fully independent, solid entity. Patience in the cold. The ingot must rest, releasing its intense heat slowly to preserve its perfect molecular structure. The silver giant emerges, a single, flawless crystal of silicon, the ultimate raw material for the green energy revolution.
Phase 2 complete. We have grown a masterpiece of science. One giant crystal. One
Preparation for the edge. The round ingot is secured with industrial force, ready to be stripped of its curves.
The diamond's bite. Ultra-thin wires, toughened with microscopic diamonds, prepare to redefine the crystal's geometry. Slicing the circle. The saw moves with surgical intent, removing the rounded edges to find the square heart within.
Taming the friction. A constant torrent of coolant keeps the temperature stable, protecting the integrity of the crystal lattice.
Squaring the circle. 4 perfect cuts transform the cylinder into a block, ensuring every millimeter of the panel captures the sun.
Nothing is lost. The curved scraps are reclaimed, destined to be melted and reborn as new energy-capturing crystals.
Precision check. We measure to the micron, ensuring the square is perfect for the high-speed robots ahead. Dividing the power.
The monolithic pillar is sectioned into uniform bricks, the manageable building blocks of solar energy.
Refining the surface. We grind away the rough edges, polishing the brick until it is as smooth as glass.
Softening the edges. A slight chamfer protects the fragile crystal from cracking, adding durability to its high-tech design. The deep clean. Ultrasonic waves shake away every microscopic particle of dust, leaving the brick sterile and pure.
Seeing through the silver. Infrared eyes look deep inside the crystal, searching for hidden flaws that the human eye could never find.
Measured to perfection. Weight and density are verified, confirming that the molecular lattice is as solid as it is pure.
The armory of light. Rows of silver bricks stand ready, the concentrated potential of 1,000 sunrises.
Phase 3 complete. Geometry and precision have met. The blocks are ready to be sliced into the world's most efficient wafers.
Strength in numbers. The bricks are fused to a carrier plate, prepared for the most delicate surgery in industrial manufacturing. The diamond web. Miles of wire, thinner than a strand of hair, create a precision cutting field capable of slicing through solid crystal. Aligning the core. The bricks descend with mathematical precision, meeting the high-speed wires that will define their new form. The cut begins. At incredible speeds, the diamond-encrusted wire bites into the crystal, beginning the transformation from block to sheet.
Taming the heat. A continuous flood of cooling fluid keeps the diamond wires from snapping under the intense pressure of the cut.
Mass creation. In one fluid motion, the solid brick is reborn as a stack of hundreds of ultra-thin wafers.
Setting them free. A chemical bath dissolves the bond, allowing each individual wafer to stand on its own for the first time.
The human touch. Each stack is checked for separation, ensuring the thin sheets of silicon are ready for the robotic hands ahead.
Deep vibration. High-frequency waves scrub the wafers at a molecular level, removing every trace of the diamond wire's path.
Stripping the damage. Acids remove the scarred surface left by the saw, revealing a fresh, pristine layer of crystal ready for light. The purest wash. 5 stages of rinsing ensure that not a single molecule of acid or dust remains on the silicon.
Driven by force. Centrifugal power flings away every drop of moisture, leaving the wafers bone dry and spotless.
The micron standard. Lasers verify the thickness, ensuring each slice is strong enough to survive and thin enough to be efficient. Hunting for flaws. We search for invisible fractures, ensuring only the most perfect crystal lattices proceed to the next stage.
Phase 4 complete. We have turned a monolith into 1,000 sheets of light. The wafers are ready to be transformed into cells.
Entering the chemical lab, the wafers are loaded into the etching line, where chemistry will change how they interact with light forever.
The transformation bath. A precise chemical cocktail begins to dissolve the surface, eating away at the silicon to reveal its hidden structure. The end of reflection. The shiny surface is gone, replaced by a dark, matte texture that drinks in the sun's rays. Stopping the clock. A neutralizing wash halts the chemical reaction, locking in the perfect pyramid structure. Purity in every drop. We use water so pure it carries no minerals, leaving the silicon surface sterile and flawless.
The air blade. A high-velocity curtain of nitrogen strips away the moisture, leaving the wafer bone dry and ready for the furnace. Mapping the terrain. Lasers verify the pyramid height, ensuring the light trap is deep enough to catch every photon. Testing the trap. We shine a light to see what returns. The less we see, the more energy the wafer has captured.
The final cleanse. A quick dip removes the microscopic oxide skin, exposing the pure crystal for its upcoming electrical transformation.
Precision handling. Robotic hands take over, moving the fragile sheets with the speed of a hummingbird and the gentleness of a feather.
Total sterilization. An air curtain creates a barrier against dust, ensuring the wafer enters the furnace in a state of absolute purity.
Preparing for the heat. The wafers are arranged into quartz racks, standing like soldiers ready to enter the heart of the furnace.
Logged and ready. Every wafer is tracked by the system, its journey through the fire recorded for total quality control.
Phase 5 complete. The trap is set. The silicon is now a dark canvas, red.
The forge of energy. Inside these quartz tunnels, we create an environment as intense as the heart of a star.
Entering the void, the wafers slide into the furnace, ready to undergo a molecular transformation that will give them the power to generate life. Creating the vacuum, we strip away the atmosphere, creating a pure, airless space where only the intended elements can interact. The chemical spark. Phosphorus gas is released, a cloud of atoms ready to invade the crystal lattice and create the potential for electricity.
Atomic invasion. Under intense heat, phosphorus atoms migrate into the silicon, creating a permanent electrical tension that will last for decades.
The thermal soak. Time and temperature work in harmony to bake the electrical blueprint into the very heart of the wafer.
A gentle exit. We lower the heat with extreme care, allowing the new atomic structure to settle without cracking the fragile silicon.
Rebirth. The wafers emerge from the fire transformed. No longer just stones, but
The chemical footprint. A thin layer of glass remains on the surface, a temporary shell that protected the silicon during its transformation. Stripping the shell. A final acid bath dissolves the waste, revealing the pure, doped silicon ready for its next layer of protection. The boundary line. A laser carves a microscopic trench around the perimeter, ensuring the electrical current flows exactly where we want it.
measuring the flow. We test the surface resistance to ensure the atomic invasion was a success across every square millimeter. Mechanical speed. With the electrical foundation set, the wafers are organized for their final aesthetic and protective transformation. The final visual check. We look for the ghost of the furnace, ensuring the diffusion is as smooth as a calm sea. Phase 6 complete. The spark of life has been baked in. The silicon is now a battery, waiting for the light of the sun.
Entering the vacuum, the wafers are loaded into the reactor, a high-tech chamber where gas and electricity will combine to create a protective armor.
The sound of silence. We remove the air to allow the plasma to flow.
Chemical mist. Specialized gases fill the void, carrying the building blocks of the sapphire blue shield that will soon cover the silicon. Igniting the plasma, a surge of electricity transforms the gas into a glowing violet fire, bonding the protective layer to the wafer with atomic precision. The sapphire shift. As the coating settles, the wafers undergo a visual metamorphosis, turning from dull gray to the iconic deep blue of solar energy.
Atomic layering.
The fire subsides. The reaction is complete, leaving behind a finished surface that is now a perfect trap for incoming photons. Settling into the blue. The wafers rest in the dark, allowing the new coating to stabilize before they meet the world outside.
The sea of blue. Emerging from the vacuum, the wafers are now unmistakable. The fundamental units of the global green revolution.
Perfection in color. Every wafer is scanned for uniformity, ensuring the blue shield is perfectly balanced to absorb the maximum amount of light.
Turning off the reflection. What was once a mirror is now a sponge, absorbing 98% of the sun's power into the silicon. Precision motion. Robotic hands move the blue treasures at lightning speed, preparing them for the final step of their electrical birth.
Sealing the energy. We verify the molecular seal, ensuring that once an electron is freed by light, it cannot escape. The factory of the future. Thousands of blue hearts pulse through the assembly line, a rhythmic march toward a cleaner world.
Phase 7 complete. The armor is set. The blue hearts are ready to receive their...
Building the foundation. We begin on the dark side, applying a solid layer of aluminum to act as the cell's ground and conductor.
Setting the metal. Intense infrared light bonds the paste to the silicon, locking the backside conductor in place in a matter of seconds.
Turning to the light. The blue face is revealed once more, ready to receive the silver veins that will carry its power. Liquid silver. This precious conductive paste is the key to capturing every moving electron freed by the sun.
The silver web. We print hundreds of microscopic fingers, veins so thin they barely cast a shadow, yet strong enough to harvest a current.
The energy highways. Thick bus bars are laid down, creating the primary channels where thousands of electrons will merge into a single stream of power.
Precision alignment. Computers verify the grid's position to the micron, ensuring the silver veins are perfectly synced with the crystal's heart.
Evaporating the past. The wafers travel through a tunnel of heat, stripping away the solvents and leaving only pure, solid metal behind.
The trial by fire. A sudden burst of heat fuses the silver directly into the silicon, creating a permanent electrical bridge through the blue shield. Building the bridge.
Locking in the bond. A blast of cold air solidifies the connection, finalizing the birth of a functional solar cell.
A finished masterpiece. The gray stone of the Earth has become a sapphire of technology, complete with a silver nervous system.
Testing the connection. We verify the bridge, ensuring every electron has a frictionless path from the crystal to the world.
Organized for power. The cells are sorted and trayed, a massive army of blue soldiers ready for their final evaluation.
Phase 8 complete. The veins are filled. The cell is alive. The moment of truth. The cells enter the darkness, prepared to meet the artificial sun that will determine their destiny.
The flash of life. For a millisecond, we recreate the power of a star.
Mapping the power. Computers calculate the electrical signature, recording the precise efficiency of the silicon heart.
Grading the harvest. Not all cells are born equal. We sort them with surgical precision to ensure every panel is perfectly balanced.
See the invisible. Improve view.
The Master Sorter. With the speed of a hummingbird, the robot organizes the army of blue cells into their respective power classes.
Aesthetic harmony. We ensure the color is as consistent as the power, creating a seamless sea of blue for the final panel. Gentle strength. Vacuum technology handles the fragile crystals, moving millions of dollars in silicon with the softest touch.
Only the best. There is no room for error. A single flaw means a cell is returned to the fire to be reborn.
Assembling the team. 72 elite cells are gathered, the perfect components for a powerhouse of green energy.
A digital identity. Every tray is marked, its performance logged into a global database of energy potential.
The seal of approval. Tested, sorted, and verified, the cells have passed their final exam.
Resting in the blue. The cells wait in a sterile sanctuary, their electrical potential locked and ready for the final assembly.
On the move, the Blue Hearts travel to their final destination, the module line, where they will be bound together forever.
Phase 9 complete. The individuals have been tested. Now, they must join forces to become a single, powerful
final fusion. Under intense heat and vacuum, the layers melt into one, creating a transparent armor that is both airtight and indestructible.
Refining the edges. We strip away the excess, leaving a clean, sharp boundary for the final structural support.
Strength and structure. An aluminum skeleton is forged around the glass, giving the panel the power to withstand the fiercest storms.
Permanent identity. Marked for life, the panel carries its own digital signature as it heads out to change the world.
Ready for the journey. Stacked and sorted, an army of solar generators prepares to travel across oceans and continents. Crossing borders. From the factory floor to the farthest reaches of the globe, the harvest of the sun begins its travel. The Great Array. In the heart of the desert, thousands of blue hearts beat. The spark of life. As the final shine, the final seed.
Powering the future. Every light, every home, and every dream is now fueled by the cleanest source of energy in the universe.
A planet reborn. We have replaced fire with light, ensuring a world that is clean, green.
A global revolution. From a single grain of quartz to a planet-wide network, the solar saga is complete.
Under the sun, we no longer just live under its light. We live by its power. Join the revolution. The future is bright. The future is solar.
A digital identity. Every tray is marked, its performance